Here are 6-digit cards. We have 1, 3, 4, 5, 6 and 8. Choose 2 cards each time to make the following 2-digit numbers. Use each digit card once. So we need to find numbers that are a multiple of 5, a square number and a cube number. Remember, a multiple of 5 is a number in the 5 times table. So all multiples of 5 end in a 0 or a 5. But we don't have 0 as one of our digit cards. So that means the 5 must be the ones digit of this number here. Now, any of our other cards could be used for the tens digit. So when any card could fit, sometimes it's best to look at our other options first, and then we can use whichever card we have left. So for a cube number, remember we're multiplying a number by itself and then by itself again. So 3 times 3 is 9 times 3 is 27. 4 times 4 is 16 times 4 is 64. Now we can't have 27 because we don't have a 2, but we can use 6 and 4 to make 64. Now a square number is what you get when you multiply a number by itself. So we can have 81 because 9 times 9 is 81. And then remember, we can use each digit card only once, and we have a 3 left, so 3 must be the tens digit of our multiple of 5. Draw the reflection of the shaded shape in the mirror line. So we have our mirror line down the middle, and if we're drawing the reflection, we need to make sure that each corner is the same distance from the mirror line when it's reflected. So if we dot this corner, we can see that from the mirror line, that's 1 square left, so we can go 1 square right and dot the point. This point here is 2 squares left, so we go 2 squares right. This point here is 1 square left, so we go 1 square right. This point here is 2 squares left, so we go 2 squares right. And finally, this point here is 3 squares left from the mirror line, so we go 3 squares to the right. And then we need to join up our points so that they're reflected and we have the same shape on both sides of the mirror line. Write what the 3 missing digits could be in this calculation. So we have a 2-digit number times a single-digit number equals 378. So first, let's find what our single-digit number could be. And the way to do that, because we have a missing number multiplication, is to use division. Now we could try dividing 378 by 2, but I can see straight away that that answer will not be a 2-digit number. And it's the same, 378 divided by 3 will give us a 3-digit answer as well. So that won't be a 2-digit number either. So let's try dividing 378 by 4 to see if this digit here could be a 4. We can do that using short division, and we get 94 remainder 2. But that's not a whole number. The number here can't be 94 remainder 2, it has to be a whole number. Now we could try dividing by 5, but I can see straight away again that we're going to get a remainder, because all multiples of 5 end in a 0 or a 5, and we have 378. So let's try dividing it by 6. Again, we can use short division, and we get 63. So because we know that 378 divided by 6 is 63, this calculation also tells us that 63 times 6 is 378. So our 2-digit number could be 63, and our single-digit number could be 6. But there are other possible solutions to this question. If we divide 378 by 7, that gives us 54. And that's a whole number, so we could have 54 times 7. Or if we try dividing it by 8, again we get a remainder, so our single digit number can't be 8. But if we divide it by 9, we get 42. So because 378 divided by 9 is 42, this calculation also tells us that 42 times 9 is 378. So we could have 42 and 9 as well. A 3D shape has 8 vertices. It has 6 faces. Each face is the same. What is the correct name for this shape? Well, if we show the shape that's being described, we can see that we have a cube. It has 8 vertices because remember, the vertices are the pointy bits, and we have 4 pointy bits at the top in each corner of our square face, and we will have 4 vertices, 4 pointy bits at the bottom as well. And we have 6 faces. There's 3 faces that we can see, but there will also be 2 faces round the back and 1 underneath, so that's 6 faces altogether. And each face is the same because with a cube, all of our faces will be squares. So the shape being described has to be a cube. Joe has some triangular tiles and some quarter circle tiles. He uses 2 triangles and 7 quarter circles to make this flying bird design. Joe makes some more of these flying bird designs. He uses 56 quarter circles. How many triangles does he use? So we know for each of the design, he's used 2 triangles and 7 quarter circles. And we also know that he uses 56 quarter circles altogether. So we need to think 7 times what is 56? Well, 7 times 8 is 56, which means that with 56 quarter circles, he can make 8 of these flying bird designs. So, because we multiplied by 8 here, all we need to do is work out 2 times 8, and because that's 16, we know that he uses 16 triangles. This regular 12-sided shape has a number at each vertex. Ben turns the pointer from 0 clockwise through 150 degrees. Which number will the pointer now be at? So a regular shape is a shape where all of the sides are the same length and a vertex is like a corner or a point. Now the pointer has started at 0 and it's turned through 150 degrees. So we need to remember that a whole turn is 360 degrees. So if this pointer started at 0 and then turned all the way around so that it ended up back at 0, that would be a turn of 360 degrees. So when the pointer moves from one number to the next, it has moved 1/12 of a turn. So if it moves from 0 to 1, that's 1/12 of the way around, so 1/12 of a turn, so we can find 1/12 of 360 degrees. And 360 divided by 12 is 30. So that means that when the pointer moves from one number to the next, that's a turn of 30 degrees. So we have 30, 60, 90, 120, and then 150. So if it's turned 150 degrees, it's pointing to the number 5. So the pointer will now be at 5. And that makes sense because remember, a straight line is 180, and so it will just be a little bit less than turning through a straight line. So rather than 6, the pointer will stop at 5. Now, Nisha turns the pointer clockwise from number 2 to number 11. through how many degrees does the pointer turn? Again, the fact that we need to know is that a whole turn is 360 degrees. So that means that when the pointer moves from one number to the next, it's moved through 1/12 of a turn, so 30 degrees. We start at number 2 and we're moving clockwise, so in the same direction that the hands on a clock move. So we start at 2, then we have 30, 60, 90, 120, 150, 180, 210, 240, then when we get to 11, we've turned 270 degrees, because 9 times 30 is 270. The quicker method is to spot the right angle. So this angle here is a 90-degree angle, and if we know that a whole turn is 360 and a right angle is 90, we can subtract to get 270. We can see that here, to get from 2 to 11, that's a 3/4 turn, so 270 degrees. 30 children are going on a trip. It costs £5 including lunch. Some children take their own packed lunch. They pay only £3. The 30 children pay a total of £110. How many children are taking their own packed lunch? Well, first we can work out how much would the children pay if nobody took their own packed lunch. So if they all paid £5. So we can multiply 30 by £5, and that gives us £150. Now, if we find the difference between £150 and £110, that's £40. So we know that £40 less was paid due to some children having their own packed lunch. So now we can divide 40 by 2. And the reason we're dividing by 2 is because £2 less was paid per child with their own packed lunch. So £3 rather than £5 meant that the children who took their own packed lunch saved £2. Now 40 divided by 2 is 20. So that means 20 children each paid £2 less. So 20 children took their own packed lunch. Now this method can be a bit confusing, but what you can do for questions like this is use trial and improvement. So what if 5 children paid £3? So 5 children took their own packed lunch. They would pay £15, but then because there are 30 children altogether, that would mean 25 children paid £5, so that would be £125 altogether. But that adds up to more than £110. That adds up to £140, not £110. So now perhaps we could try 10 children, each paying £3. 10 times 3 is 30, and if 10 children had their own packed lunch, and there were 30 children altogether, that means that 20 children would have paid £5 for lunch as well, but that adds up to £130, not £110. So we're getting closer, but what if 20 children paid £3? 20 times 3 is 60, and that means there would have been 10 children paying 5, because remember, there have to be 30 children altogether, and 60 plus 50 is 110. So we know that 20 children are taking their own packed lunch. Calculate the size of angle X. So we have this angle here, 132 degrees, and this angle here, 70 degrees, labelled. And it can be tempting to think that we need to do something using only these numbers. So some children try 132 minus 70, but the answer can't be 62. we can see that we have an obtuse angle here, and 62 degrees would be an acute angle. So what we need to do is find some of our other angles first. We need more information in order to find angle X. So notice here we have a straight line along the bottom, and we know that angles on a straight line add up to 180 degrees. So we can find this angle here by subtracting 132 from 180, and we might need to use column subtraction for that, but we'll get 48 degrees. Now we can find this angle here if we remember that angles in a triangle add up to 180 degrees as well. So 48 plus 70 plus whatever this angle here is will total 180. So if we subtract 70 and then 48, so subtract 118 altogether from 180, we get 62. So now we can find angle X, because here we have a straight line. We know that this part here, this angle here, is 62, so this angle here has to be 180 minus 62, because angles on a straight line need to add up to 180. Again, we might need to use column subtraction, but we'll get 118 degrees for angle X. Write the missing numbers in the sequence. We have 467,050, 468,050, 469,050, and we need to write the numbers that come before and after. So if we look at the digits that change, it's our hundred thousands, 10,000s, and thousands digits. So we have 467, 468, 469, and then we know that the number after 469 is 470. So that means the number after 469,050 is 470,050, because the 050 stays the same. It's only the digits that we've highlighted that change. And we can see that with this sequence, we're adding 1,000 each time. So here, to get our missing number, we need to subtract 1,000 from this number. But because we've already highlighted our digits, rather than 467, we will have 466 in our hundred thousands, 10,000s, and thousands place, and then the 050 will stay the same. So that's 466,050. Annie has collected 10 pence coins. They are worth £10. How many 10 pence coins does Annie have? Well, we know that £10 must be 100 pence, because we can multiply by 100 to change pounds into pence. So she has 1,000 pence, and each coin is worth 10 pence. So to find the number of coins, we can divide 1,000 by 10, and that gives us 100. So Annie has 100 coins. The other way to solve this would be by counting up. So we know that £1 is the same as 10 10-pence coins, because 10 times 10 is 100, and 100 pence is the same as £1. But they are worth £10 altogether. 1 times 10 is 10, and 10 times 10 is 100.